Hello everyone, and welcome back in our industrial warehouse design series, in which we are going to try design our connections and of course trying to do a preliminary material survey and cost estimate using Autodesk Robot. Of course, this video series we're moving in tandem with a theoretical video series, and the link of a playlist that basically has them ordered in a logical order is going to be shown on the top right. I know that I have not done a lot in the theoretical series so far. That is because I think that I have covered for now what I need. So today we're going to basically not design all the connections, but take a look on the connection design GUI of Autodesk Robot and try to understand the different options in those connections. At the end of this video, I will be doing a material survey and a cost estimate using Autodesk Robot. And well, with that being said, sit back, relax, and enjoy the show. Okay, now I'm assuming that you have already finished designing all the sections by this video. So I'm assuming that you have basically finished designing all the members in this warehouse and have now reached adequate sections. So how can I design the connections for this warehouse? Now, let's take a look on how we can do this. First of all, I'll click on the layouts here and go back to geometry. This is my main layout. Now, I think my calculation has been done, but I will calculate again just because I'm a little bit worried that I have not done that. So I'll finish my calculations and, well, prepare my design. Yeah, 16 was ULS, and we've explained before that ULS here contains all the combinations that we have defined in our automatic combination that was explained before in the video linked above. Also, we have finished designing our members in the same video, I guess. So now we have, of course, I left some of the parts for you where you can do iterations, but I'm assuming now that you're ready and that you finished designing the members. So the connection I will be focusing today is going to be this connection, the knee connection, the beam-to-beam connection, and the beam-to-column connection. Maybe other connections will be coming later. I might even consider doing a full connection video, just a standalone one, to explain all the details and dive deeper. Today I will just scratch the surface of the robot's abilities to design connections. So I click on this beam or rafter, and I hold the control button and click on this column. And now I have two elements. I can just go to design and select steel connection design. Now when you select steel connection design, you can click on this, which is new connection from selected elements. This means that he will read the selected elements and create a connection for you. If you click on that, you notice that you have a frame knee here, and he's telling you, hey, wait a minute, if you change this, your calculations will be obsolete. Yes, I know. Let me just accept that. So now I have a frame knee definition window. This definition window is the same as if you have clicked here, new connection, or even clicked here, frame knee connection. The difference between this wizard and this frame knee is that if you click on this frame knee, it defines it from scratch. You have to apply everything. If you click on the wizard after selecting two elements, then it will import the characteristics of those two elements. Take a look at this. Look, you have bar number 327 and bar number so-and-so, because one of them is the column, one of them is the beam. Bar 327 is this bar. If you look here, this is 327. And here's even the bar numbers, if you don't believe me, 327. And bar number 325 is the beam, which is perfectly fine. And from that, you can see that everything is basically added automatically. You have the columns, you have the beams, you have the heights. All of this is added from the properties of the problem. And that's the reason why I said you should have finished your member design before you go to your connection design. Now, those would be a nightmare to apply if you want to apply a new connection. If you go to plate, now here you have the option to provide a plate if you want to have an upper bracket column, like you want to put a bracket like this. Now, those affect the safety of the connection. I usually do not like to add anything unless I have a reason to do so or my connection is not safe. I will go to plate. The front plate is a must because there must be a connection, right? There is a plate. And you can change the material. I think I used 275 as material. Did I use 275? Yeah, 275. So I should be using 275 everywhere, right? Okay, fine. Because I want to use 275 the same. Now it makes sense to use the same steel material like the members. You could change. You could use a different steel material, but why? Like I don't get the idea why. You can put brackets for column flanges and lower column flanges. Those are basically brackets. And this bracket is an extension on the flange to help basically support the structure. This happens if your flange fails due to excessive loading. Now, I will not be making a bracket for the column flange, a small bracket. If you go to brackets, the bigger ones, you can see that there is a bracket automatically defined with its height, length, width, web, and flange. Now, how does it do that? How does it know all those information? Well, I have defined the bracket during my modeling. And remember that the bracket was, I think, 10% of the length of the bar. The length of the bar was 15 meters, so 10% of that is around 1 meter 500. That's perfect. You don't need to apply all those things yourself. And that's the reason why detailed modeling sometimes helps you save a ton of time when you want to design the bracket. Of course, you can artificially add another bracket. I will not. This bracket is basically the haunch we have defined. You can even add a stiffness plate if you want, but I will not. This is an extra stiffener. If you feel that the connection is not strong enough to resist against bending, you can add a stiffener here or a stiffener here. But I think like we are way past that. Oh, by the way, I forgot that this is now a bolted connection. You can go through the welded connection, which would change some of the options. My bad, I forgot to mention that. Like if you click on bolted connection, you can see suddenly that you have a plate and bolts. If you go to welded connection, the plate disappears and the bolts disappear, and of course you have welds. So we are now in the bolted connection domain. This is the brackets. I will leave it as is because it's taken from the robot bracket we have defined. If you go to bolts, you can select the diameter of bolts you want. I usually leave it as is. I only change them if it doesn't work. For example, the number of bolts is excessive. In that case, I would change the diameter of the bolts. Like this, I don't change unless I need. The definition of needing here is that the number of bolts is not enough. So the first thing is I would change the diameter or even add some extra rows of bolts if I need to. But I don't think I need to, so I will keep them as N5. Horizontal spacing E is here. This is the spacing between the bolts. It's sometimes crucial if you want to resist moments out of plane of the frame, like moments that push from wind load pushing from the left to the right, for example. So that's kind of cool. You can see all the sections, all the stuff explained here. You would think it's strange, but it's not strange. If you click on symmetry, you would think, wait a minute, isn't symmetric always better? Like if you click on symmetry, you would think symmetry is always good, symmetry is always better, or equal spacing or something. Oh wait, I clicked and unclicked, so now it's equal spacing. I messed it up, right? Okay, there we go. You would think, because if I click equal spacing, it would overwrite this. You would think, why equal spacing? Equal and symmetry should be good. No, it's not always good. It's not always good because we know that usually on a frame knee, there is a negative moment, or I think it's called hogging moment, that is affecting this knee, frame knee. And when you have a negative moment, the tensile strength, the tensile forces are going to be on the top side, and the compressive forces are going to be on the bottom side. And the compressive forces can be carried by bolts and the bearing itself, because the beam bears itself is bearing or bearing on the column. But when you pull on the top side, there is no bearing interaction at all. There is only bolts. So that's why a larger amount of bolts on the top side makes sense, and having them as far away as possible also makes sense. So I will not be activating equal spacing or symmetry. Stiffeners is actually a good thing. Wait, why is it using this material? Okay, I'll just 275. Stiffness might be a good thing. You can add stiffness. Wait, what? He's already adding stiffeners, horizontal stiffeners at column. He's already adding them. Yeah, that's okay. I thought that I needed to click them. He's already adding them, which makes sense. He's adding a stiffener here because you have maximum tensile forces or stresses. And he's adding stiffeners here because you have maximum compressive stresses here, which totally makes sense. You can even make vertical stiffeners for the beam. I don't know. Maybe you want it, maybe you don't. You can even make this cool stuff, which is like next level. This is used to, like, if the stiffener here is not enough, you could make a truss. It's not really a truss, but you can make a truss-like interaction between the top stiffener and the bottom stiffener to try alleviate. Like, look, you have. Let me explain this. Like, look, you have huge compressive forces being applied from this, tensile forces, sorry. You have huge tensile forces being applied on here because of negative moment, and huge compressive forces being applied like this. Okay? And sometimes even the compressive forces might be too powerful for the stiffened flange to carry, so you would take part of the compressive force and distribute it along the length of the flange, which means that like 80% of the compressive force will be resisted by this, and like 20% will be resisted by this. It's kind of like shifting part of the forces on another region to help out in the carrying of that force. This is something that you do not see usually in ordinary structures, so I leave it. Code parameters. What are the things you want to run? This depends on the code yourself. I will leave it for you to read around because you have multiple, according to the Euro code, you have, and by the way, we are using the Euro code so far. You have like all those, I mean, look, 5.1, if you open a Euro code, you see what it means. 3.4.1 has a meaning in Euro code. So I will not be, I'm not explaining Euro code today, so I'll just leave it as is. If you click on apply and OK, you have a frame knee, but it's not yet calculated. If you go to connection view, you can see the frame knee, but is it good enough or not? We don't know. So how do we know that? Well, you have here a tick mark. You have here design connections from a structure. If you click on this, your connection list, you have only one connection. Do you load cases? I just click on code combination because I don't want him to design for load cases. I want him to design for my code combinations, and you can see him selecting automatically combination 16. I click on calculation, and now he is doing some stuff. 12%, okay, that's really, really good. And you can see the connection details here with all kinds of cool stuff, with all the information you want, as well as detailed calculations as to, of course, he's using ULS3 because there are like, I don't know, 40 combinations. He was using the largest one. And you can see him doing all the design calculations, and he's giving you references as to from where he got the equations. This is a very long calculation, which is kind of cool. Well, did we finish? No, we have still other connections we want to design. So I go to structure. Let's take a look. Which connection should I use? I will be using, you know what, let me just do the apex connection. So those two beams are the ones I want to take. And I will only do the apex connection between the two beams, not between the gable and. So I select on apex here. I select here a new connection wizard, which will import the two apex connections. And of course, here, it's repetitive now, right? I will use the same material for all components, S275. It's importing everything automatically. It has a plate. It puts a bracket automatically because I defined them. Bolts or welds, I think I selected bolted, so still there is bolts. Yeah, there is nothing to say. It's just follow the entire thing, the same thing. So apply. Okay. I will also define me, or I can just run the analysis very quickly, like design of steel connections. Code combination 16, and now it does its magic, and it's 46%. Okay, that's a little bit higher, but fine. We go back to our structure. Let me just take this, for example, the gable beam with the gable column, and now I'll just go here again, create me a new connection for those two dudes, and yeah, it's something called a column beam, not a frame knee. I'll just, it's just repetition now. So I'll just apply, OK, and calculate. And of course, because, now don't be fooled by this 0.02. The reason why it's 0.02 is because there are no forces applied on this. Because, I have not put any forces here. Also, I have not put purlins here, something that you should be doing. Speaking of purlins, this is where things get really interesting. I don't think robot will be able to do this. So let me just try that. Those are like the main connections that will take time in the design. But what about other connections? Like, for example, let's say for example this 1, 2, and 3. Now this is where robot becomes a little bit weaker, because if you click on new connection, it will fail to find the connection. It says that it detects a common node 1, but it just doesn't understand how this connection looks like. Of course, you can manually define a connection. I think this is the one, gust plate. But it's kind of a pity that robot is unable to see those two things. If I use those two things alone, will it see it? No. Look, the point here is not to show you everything that is green and roses. I don't want to show everything as being so nice and cool, because sometimes there are limitations of the software. And for example, here, if you select those two things, it just doesn't understand that those are connected, just doesn't get it, which is kind of annoying. For example, here, if you select the purlin here and the purlin here with the column here and select new connection, you can see it failing again. So I have seen some comments saying that robot is a little bit weak in the connections. I want to say the following statement. I want to say that robot is a beast in connections only if it's able to see them. Like if it's able to see the connection and basically implement it from the structure, then Autodesk robot is a beast. But if it's unable to see the connection, then this is where things get annoying, because like you see those cool abilities in front of you, and you're not able to use them. This is kind of a pity. So if the connection you're defining works, then you are happy because you have robot's full powerful ability to design your connection. If robot doesn't see the connection, then it becomes kind of a pity, right? Like, you're doing so good, why now? Now, I heard about a software called, or a plugin, I think. I need to check this out. I heard about something called Idea Statica, and I need to check this out. If this supplements robot in the connection design, then I might be adding this to my robot series. If it doesn't, then I will just remain silent. So that's at least partially what you're doing with connections. Now, are we finished? Of course not, because I mentioned that we want to do a quick quantity surveying and cost estimation. Now, how do you do that? Well, actually, how do you do that? I click on Geometry now. If you click on Tools Cost Estimation, you are greeted with this window. And now we want to make a cost estimation of our warehouse. Of course, here I'm not showing you the entire thing. I'm only showing you how it's done. Also, I cannot under any circumstance give you a good cost estimation here, because my viewership is almost all over the world, so each region has its own cost. But still, let's say we want to cost estimate this frame. So what were the sections I used in my frame? The truth to be said, I forgot. I need to check very quickly. I want to make a new group, and this group I will call it, I don't know, rafters, for example. Now here it asks you for a price and the transportation. I don't know the prices. I am not living in the region. $20, I have no idea what this is. Of course, I have no idea what the prices are, because remember, it varies from one region to the other, especially the workmanship prices. And also sometimes you have transportation costs, which could include import fees. So I put another $20 here. The unit is kilogram, which means those prices are for each kilograms. And now I'm regretting, I think I put too much here. And the currency is in US dollars. The prices, you'll have to check your local region. I will click OK, and now I have a group called rafters. If you want to add protection to it, like default protection, I just put here $5 per kilogram. I think this could also be coating or something. Wait, I made a mistake. I think I deleted my rafters, so just add them very quickly. This is section IPE 400. It's under the rafter group, under default protection. And another group, I think I called it purlins, right? Purlins. And it's my ZCE. Of course, you can add more groups, but I think those are two enough. That is also called the loss coefficient, because you will not be using 100% of the material, so you can put 90% if you want, or 1.1, the inverse of it. I will leave it, and I will apply it. Now I have ZCE. Wait, did I save the other one? I think I didn't save it. Okay, I will just run the analysis very quickly, because sometimes you need to run the analysis to refresh. Okay, see, it got refreshed. Perfect. To refresh your stuff. Yeah, it tells you the sections have been updated. Okay, fine. I'll just leave it for now. And you can see now that the IPE section, the ZCE section, you can see the total weight. The total weight, this is material surveying, the material price, the transportation price, the protection price, and the total price in US dollars. Of course, my prices are not correct, you should get to your local vendors and ask them about the prices of those sections. But wait, this is not sufficient for me. I want to have a list of each section and how long each section is. So this list is not good enough for me. I want to have a material survey for the lengths of the sections. Well, fear not. While you are in the material survey, if you click on geometry, you will see a new geometry table. Like if you are not in the cost estimation, if you click on geometry, you see the regular geometry. If you go to tools, cost estimation, and apply, and when you are on the cost estimation window, then if you click on geometry, things change. You can see some tables. But what is not boring is something called quantity survey table. If you click on this is where it becomes really interesting. You can see S275 material, IPE 400, 18 pieces, length so and so, IPE 600, 4 pieces, length so and so, IPE 600, 4 pieces, another length, IPE 600, 2 pieces, another length. This is a quantity survey as of not cost, but each section, the number of pieces you want, and the length of each piece. So this might be interesting if you want to go into details as of what the material survey is for your selection. So I think that's fair enough for this project. Finalizing it, if you want to design the supports, this becomes a very easy task. All you have to do is to select one of those supports and be very careful. I selected 2 nodes. I want to select only one. So I will zoom in a little bit and select this node. I select this node, that's a support node. I'll go to design. I'll go to provided reinforcement of RC elements, and you can see robot will see it's a foundation and will import the foundation. I have a detailed video talking about foundation design, so please take a look on that. If you click on foundation here, it will design the concrete part of the foundation, only the concrete part. But as you know, there are 2 parts of a foundation. There is a concrete part, which I've explained in a previous video, which I will link above. So this is a really long thing that you can see in the other video. And there is something called the steel part of the foundation. The steel part of the foundation is designed by a connection. And how do you design a connection? Well, I click on this, and instead of going to design provided reinforcement, I go to design steel connection design. Okay? Because there are 2 parts of the foundation. The first part is the concrete part, and the concrete part, you take the node and click design, provide reinforcement, and it will design a foundation concrete for you. And there was a video about this before. If you want the steel part, you click on the steel column like this and click new foundation, new connection. And you can see it now because you clicked on new connection. See, when you click on the node and select design provided, it will make the concrete part for you. If you click on the same node and column and click connections, you'll understand you're talking about the base plate, because there is a base plate on the concrete foundation. Once again, you can basically take a look on all those things on the base plate and how you're going to connect the base plate. I will leave those things for you. And look at this. You can even let robot do a foundation for you, but here, of course, you will not see the reinforcement. Like this will be a concrete block. It depends on the amount of forces you have. If you have large amount of forces, maybe a full-fledged reinforced concrete foundation would be required, and in that case you would say design provide reinforcement. If it's a small one, then maybe this would be enough. So pick and choose your approach for this. If you click on OK or apply and calculate, then you can get the design of the foundation of that with its anchorage. Here, there are no details as for the foundation, the concrete foundation used here. There are absolutely no details. Okay? There are no details because for him, the foundation is not, the idea here is to design the connection to the foundation. not the foundation itself. So after you finish the connection to the foundation, you can use the dimensions of the foundations to go back, and this becomes a back and forth issue. Like, I finished my connection design here, maybe the foundation is not adequate, so I go here to my foundation design, provide reinforcement, and maybe input my dimensions here and run the analysis and check if it works or not. If it doesn't work, maybe I will do an analysis here and get the values from here and go back to my steel design connection and go to my pinned column base and change those values here based on the results I got from the foundation design. So it becomes a kind of back and forth, and I think you have all the skills necessary to navigate this back and forth in this phase. So yeah, that's everything I wanted to talk about today. I hope that you enjoyed the video. Of course, before I finish, I want to give a huge, massive shout out to our dear channel members whose names are going to be shown on the screen. I want to thank them from the bottom of my heart, as their generous support allows us to do all those videos and all those series efficiently and on time. Thank you very much for your support, and for that I want to thank you from the bottom of my heart. With that being said, I hope that you enjoyed the video and that it was beneficial for you. Of course, if you have enjoyed the video, then please like, share, comment and subscribe, especially subscribing, because it helps increase the reach of my channel. As per usual, this is the Civil Engineering Essentials channel, and we will catch you in the next video.